students, so Mr. Alent here. We're going over the 10.4 notes. So we did 10.1 in the previous video. We are skipping sections 2 and 3 from the book. We're just jumping right to section 4, so that wasn't a mistake. We're going to go from 1 to 4. In the 10.1, we discussed the identifying, classifying of these three-dimensional objects, prisms and pyramids and cylinders and cones, right? And now we're going to look at finding surface areas, and we're going to focus right now on prisms and cylinders. We'll get later to the other guys, the cones and the pyramids, but prisms and cylinders. And to do that, and I'm doing these notes a little bit different. I made a video already, and it turned out to be way too long to go through these examples and to go through it. So these examples are already filled in, so do your best to fill in what you see, but I'm going to try to talk you through what I did and how each of these were done. So still do your best to follow with me and look at what we got here, copy down what you can. If you have to watch this video multiple times to do that, fine. Pause it, rewind, whatever you got to do. Okay, so to talk about surface area, right, surface area, we're going to talk about several things, and that is, first, what is a lateral face? A lateral face is a face of the prism or pyramid that is not a base. So the lateral faces are the non-base faces. All right, so in this example, this is like the one from 10.1. This is a trapezoidal prism because we got these two identical trapezoids that are parallel and congruent, and they're connected by these rectangles. And so those are our bases, those trapezoids. So the lateral face, it's any of those other rectangles, the one on top, the one in the back, the one on the bottom, the one kind of on the front here, on the side. These are our lateral faces, okay? And then a lateral edge are the edges that are not sides of the base, right? So here's the base, this trapezoid, right? So none of these sides are considered a lateral edge. It's these guys. The ones connecting the bases are your lateral edges, okay? All right, surface area. Now, surface area is the total area for all the faces and bases, or it says, or curved surfaces, if you're talking about a cylinder or a cone, right? There are some curved surfaces. They're still part of it. So it's just, what is the total area of everything on the outside of this three-dimensional object? That's surface area. It says lateral surface area, or we'll just call it lateral area. The lateral area is the area of the lateral faces, which means you're not including the base, right? So it's the area of everything without the bases, right? So up here, it's the area of all those rectangles combined, but not including those trapezoid bases. Okay, so here, and I did a lot of highlighting and stuff. This is the key here. This is true for all prisms, and so you have to kind of master 10.1 by being able to classify what is the shape. Here's an example. This is a hexagonal prism because I've got two identical hexagons connected by all these rectangles. It's a hexagonal prism. So I would use these formulas. All prisms use these formulas, okay? And the lateral area, so LA stands for lateral area, is P times H. And we have to define those in a minute, we will. Surface area is P times H plus 2B. Well, that P times H, that looks like this, and it's not a mistake here, right? To find surface area, you can do all the areas of the rectangles plus the area of the bases, and that's exactly what this is showing. So lateral area is in the formula. That's the only reason really we talk about lateral area, is to get to surface area, which we need that area to be able to get to surface area. Okay, and a few notes, and this is a couple of really important pieces here. H stands for height of the prism. It's the distance between the bases. Highlight that. Okay, we're so used to thinking height has to go up and down, but it does not. We're in three-dimensional land now, and the height is defined as, for a prism, the distance between those bases. Okay, because again, these are 3D objects. These are real objects that you could move and twist and turn. So what's the height then, right? It's arbitrary if you're just thinking up and down. But if we define it as how far apart of the base is, now it doesn't matter how we orient it, we know what the height is. Okay, so if you're looking at this picture again, right, the bases are the hexagons, so what's the height? It's how far apart are they? That's our height right there. Okay, and then the P in the formula stands for the perimeter of that base. And so like this hexagon here, right, it's got this side length of 6 right there. So the perimeter would be just adding up all those sides, right? You just got to remember what perimeter is. You add up all the sides around to get the perimeter. So there's 6 sides here, all of them at 6 feet. So the perimeter of this base is 36 feet, right? And they're the same bases. Okay, and so in our first example here, we were finding lateral area. Lateral area is P times H. So we take the perimeter of 36, we just found right there, multiply that by the height of the prism, which is 17, and that gets us a lateral area of 612 square feet. So that's not too bad, right? Surface area then says, okay, well, I'm going to take that lateral area I just found, right there, the P times H, which was the 612, and I'm going to add to it 2b. Now, capital B, this is capital B on purpose. It is not lowercase b like last chapter. In chapter 9, we saw a lot of lowercase b's, which stood for base. You know, like we had the trapezoid with a B1 and a B2. The 2 parallel sides are bases, right? And B1, you know, little B1, little B2. This capital B is something totally different. It is not an edge. I don't know how many times I see people make a mistake and throw some weird number in there from the picture because it looks like a base edge. Capital B stands for the base area, the area of those bases. It's the area of the hexagons. That's capital B. Capital B changes depending on the prism. It's whatever the prism has for a base. You know, if these were triangles, if this was a triangular prism, capital B would be 1/2 little b times h, right? And that'd be little b and h of the triangle, right? If it was a rectangle, it would be 2 times length times width, right? Capital B is length times width. You know, this is a hexagon. So what's the formula for the area of a hexagon? And that's the next piece down here. The base is the hexagon. And the hexagon we found by doing 1/2 times the perimeter times, remember little a stands for the apothem. All right, so this again back to last chapter. Hopefully you kept those notes. Look at those over and over. Keep them with you as you do this because we're going to need those area formulas. So the hexagon formula, 1/2 P times A. Well, P, it's still that same P we did up there, so that's good. So it's the 36. The A was given here, that's nice. The A, little a apothem is 5.2. So we're going to multiply those, divide by 2, and you get 93.6. And so that is our base area, 93.6. And so 2 of those, because there are 2 hexagons, 2 of those base areas, plus that lateral area, all right, will get us our total area, surface area for this hexagonal prism. Okay, hopefully that kind of made sense there. Do your best. Like I said, watch it over and over if you have to. You guys are always welcome to come see me on our weekly Zoom on Wednesday. I had the last 2 weeks in a row, nobody has come. So come and see me. Come and say hi, ask questions. I get a lot of questions via email, but then nobody's coming to see me, and where I could really answer them a lot better. Okay, if you turn the page, we're looking now at cubes. A cube is a prism, technically. But there's also easier ways to look at it than going through what we just saw. And that's because, again, if it's a cube, then it's made up of squares. And what we know about squares, all the sides are the same. So if you're looking at this cube here, if there's an 8 centimeters on this side, and it truly is a cube, then every edge you see has got to be 8 centimeters because they're all squares. All 6 faces here, right, the kind of front and back, the top, the bottom, the left, and the right, all 6 squares are identical, and they all have a side length of 8 centimeters. And so it's really nice then, if you're talking about lateral area and surface area, you've got s squared. S squared is the area of one of the squares, right? S times S, length times width, right? S times S is S squared. So for lateral area, you've got 4 of them, right? 4 rectangles, or excuse me, 4 squares going around, connecting the 2 square bases. And with a cube, you would kind of just decide which one's going to be the bases if we were going to use the prism formula. But we don't need to. That's why we have these. We're just going to say, okay, well, 4 of those sides would make up a lateral area. Surface area then is all of them, all 6 squares, right? All 6 squares added together. Their areas. And another way to say that is 6 times the area of one of them. So really easy. I love cubes. They're super easy. If you know the side length, you just plug it in. So 4s squared for lateral area, so 4 times 8 squared. The 8 gets squared before you multiply. Don't forget rules of order of operations. 8 squared is 64, so 4 times 64 is 256. Surface area, 6s squared, so same, 8 squared is 64. 64 times 6, 384 square centimeters. So cubes are nice, super easy. Okay. Again, you can come back and rewind and write that stuff down if you need to, but cubes are really sweet. S just stands for side length. Bam, they're all the same because it's a cube. Okay, now cylinders. I did get a lot of emails about kids who said they were really struggling with the circle stuff. Guys, one thing I love about circles, they're actually the easiest ones. And so I'm not sure where a lot of the confusion was coming from. And I think it's the 2 pi stuff. I think some of us get a little bit confused with 2 pi, but the formulas are really the easiest of all of them that you're going to see because there's only 2 things to know for a cylinder. The radius and the height. There's nothing else to measure here. There's nothing else to find. There's nothing else to... That's it. We just have a radius, we have a height. That's it. There's nothing else for a cylinder. So the formula is really easy. There's just 2 things to plug in. Just put them in and chug away. You know, so if I'm finding the lateral area... Now, the lateral area of the cylinder, that's kind of the curved, flat surface that's connecting the circles. The circles are the bases, right? That bottom circle and that top circle, those are considered the bases. So if we're talking about lateral area, it's the area of that guy, that kind of flat, you know, if you're talking about a tin can, it's the sides of that tin can, it's not the circles. So 2 times pi times r times h. Remember, pi is just a number, guys. It's 3.14, right? So this is not something to freak out about. So it's going to do 2 times pi times the radius. Well, that's 9 here, times the height, which is 22. 2 times pi times 9 times 22. And depending on the problem, like what it asks for, if it says leave it in terms of pi, you would leave it as 396 pi. 396 is 2 times 9 times 22, and that pi is still just kind of there multiplying. It's clean, it's nice. There's not a lot of, there's no decimals and rounding. 396 pi square yards. So if it says in terms of pi, that's what it means. If it says round to the nearest tenth, then that means, okay, take the 396, go ahead and multiply by 3.14. And actually what I recommend is using the pi button on the calculator. 396 times the pi button, and that gets us 1,244.1, right, to the nearest tenth, 0.1 square yards. In word problems, you always want the decimal because it does make more sense to us in our minds if we're, going to, if you think about, surface area, where you talk about painting some object. If I'm painting the object, I'm going to cover the entire surface of that object. So really, I'm painting the surface area. So I would need to know how much the paint covers, how much a can of paint could cover area-wise, and then, you can think of how problems like this might go. And it makes more sense to talk about it with the decimal than in terms of pi. Nobody gives you, you go to the store to buy a can of paint, it doesn't say it covers, 12 pi square feet. It tells you some decimal number, right? Okay, now finding the surface area. Again, the lateral area is that 2 pi rh, right? We've already done it. So this 396 pi, we've already got that. Boom. We just need to add in 2 pi r squared. Now remember, this is, ignore the 2 for a second, pi r squared is the area of a circle. Pi r squared, area of a circle. So this is going to get us the area of one of the circles. But we have 2 identical circles, which is why we multiply by 2, right? This is just like the 2b for a prism, right? It was lateral area plus 2b. Well, it's the same thing here. Lateral area plus 2 circles, 2 pi r squared. And so the r again was 9. 9 squared is 81. 81 times 2 is 162. So 396 pi plus 162 pi is 558 pi. Again, so if it said leave it in terms of pi, there it is. It's clean, it's nice. If it says to the nearest tenth, then go ahead and multiply 558 times the pi button in your calculator, or 3.14, and that's the 1753.0 square yards. Okay. This still took almost 15 minutes to talk, so you can imagine how hard it was to complete this while I was writing. But hopefully that makes a little bit of sense for you. Watch the video as many times as you need to, and again, come see me on that weekly Zoom meeting that I have posted in our Google Classroom. Come get those questions answered face-to-face on Zoom, or at least hear my voice if you don't have a camera. But it's easier to answer questions than it is for, I've had several students just say, Mr. Allen, I don't get it, in an email. It's like, well, how do I answer that? There's nothing I can do for you. So you've got to come see me at the weekly Zoom. And if we have to set up more times for the Zoom, fine, but let me know. I had, like I said, the last 2 weeks, nobody's come in and seen me. So come and see me. Let me answer some questions for you. That's why I do it. I'm on there anyway. So, all right, guys, good luck. We'll talk to you later.